Part 5 of Unit 12 is about the acidic and basic properties of salts. Okay, so let's look at some reactions of ions with water. Anions react with water in a hydrolysis reaction to form hydroxide and the conjugate acid. So anion X, negative charge because it's an anion, plus water is going to split this water, break it apart. That's what makes it a hydrolysis reaction. Is going to produce the conjugate acid HX and the hydroxide ion. So the important thing to remember here is that anions make solutions basic because they produce hydroxide ion. Cations, especially metals, cause hydrated complexes or hydrated complex ions to form, and one of the products of that reaction is hydronium that lowers the pH. So an example reaction there, we have iron hexahydrate, H2O6, and this is it's supposed to be a bracket. This is a complex ion with a +3 charge. It's going to react with water to produce another complex ion, iron pentahydrate, with a hydroxide on the end of it. It's going to give it a +2 charge, and the other product is a H3O, a hydronium ion. Sorry, that was a hard one to copy down. So what happened here is this complex hydrated ion gave a proton to water. So instead of having 6 water molecules as part of the complex ion, it only ended up with 5 and an OH, and it produced a hydronium ion. So the important thing to remember there is that cations produce hydronium that lower the pH. So cations make solutions acidic, anions make solutions basic. Another thing to remember about cations is they become more acidic as the charge increases. So an iron +3 is going to make a solution more acidic than an iron +2. And they also become more acidic as the size of the cation decreases. So a smaller metal ion is going to be more acidic than a larger metal ion. Let's talk some more about the effects of cations and anions. Anions that are conjugate bases of weak acids will increase the pH, while conjugates of strong acids will not. So if we have a strong acid, it's going to have a very, very, very weak conjugate base. It's not going to affect the pH at all. Now the conjugate base of a weak acid, it will affect the pH a little bit. It will increase it. So the conjugate base of a weak acid will increase the pH. Now this next point is basically the same, except it's talking about conjugate acids. So cations that are conjugate acids of weak bases will decrease the pH, while conjugates of strong bases will not. So a strong base is going to have a very, very, very weak conjugate acid, not going to affect the pH at all. But a conjugate acid of a weak base is going to decrease the pH, make it slightly more acidic. So a conjugate base of a weak acid will slightly increase the pH. A conjugate acid of a weak base will slightly decrease the pH, slightly make it more basic or more acidic. And when a solution contains both a weak acid and a weak base, the effect on the pH depends on the Ka and the Kb values. Whichever is higher, Ka or Kb, is going to affect the pH more. The last thing we're going to talk about is oxyacids, and acids with oxygen in them. For a series of oxyacids, acidity increases with the number of oxygens. So hypochlorous acid, HOCl, it's got a pretty low Ka value. Chlorous acid adds one more, and the Ka increases. And when we get to chloric and perchloric, those are actually our strong acids. They dissociate 100%. They don't have a Ka value. So the more oxygens we add to polyatomic ions and their acids is going to increase the strength of those acids. Your question for this section: which of these conjugate bases will have a greater effect on the pH of a solution?